Okay, today we're going to finish up this Cluck and Shelley worksheet that we were working on in groups on from Friday. We did not get to all of the questions in all of the classes, so we're going to kind of rewind a little bit, answer a few of these questions as we go. I know not everybody has their sheet from Friday. A lot of people threw it in the trash because I said it wasn't an assignment, and we've kind of gotten in the habit of thinking if it's not an assignment, then that's not useful in any way, which is not very smart. But anyway. Got a little basic graph going on here. On Friday, we were able to discover using the charts, we figured out some equations that went along with Cluck and Shelley. And Shelley is the green line, the egg that starts rolling down the hill. And Cluck, which was the mother, is the red line. Remember from Friday that it took 2 seconds for Cluck to notice that Shelley was rolling down the hill and before Cluck got started running, which is how come her distance starts off at 0 after 2 seconds have gone by in the graph. Okay, let's see if we can answer some of these questions. Okay, number 10 asks, how far down the hill will Shelley be when Cluck begins chasing her? How did you determine the answer? Okay, well, how far down the hill will Shelley be when Cluck begins chasing her? Okay, well, yeah, right there we just said is where Cluck begins running, and we just need to see what's going on there with Shelley. And let's see what it was. Okay. Um, I heard an answer. Somebody, how many feet? 40? Um, yeah, probably not. It's not nearly that far. How far will she be down when Cluck begins chasing her? Well, here is where she begins. Okay, so we've got Shelley right there. Looks like about 8 feet or something like that. And I do believe we still had the chart we could go back to if we needed. Okay, yeah, there's Shelley's distance. After 2 seconds, Shelley had traveled 8 feet down the hill. So we could use the graph, we could use the chart, we could program the equations in our calculator and use the chart from the calculator. Anyway, it looks to me like we've, from the chart as well as from the graph, we can see that Shelley has an 8-foot head start by the time Cluck begins running. On number 11, it asks, how far will Shelley and Cluck be after 4 seconds, 6 seconds, and 8 seconds? Well, let's take a look. All right, let's see. After 4 seconds have gone by, well, here is my grid line for 4 seconds. So we just really need to see what is going on with the two birds as 4 seconds is there. Well, how about Shelley? Let's pick on Shelley first. What's it look like? Keep in mind, I know it's kind of hard for y'all to see, but every 2 lines is 5 seconds. So there's 5, 10, 15. It looks like Shelley might have traveled around 16 feet maybe. Okay, and again, we can verify that from the graph or from the chart. Okay, I think Shelley's gone 16 feet. And how about Cluck? Looks to be about 10 feet. Okay, after 4 seconds, let's go back a couple of pages and take a look. After 4 seconds, 16. That's kind of what we figured from the chart, and it looks pretty clear that Cluck had traveled 10 feet after the 4 seconds. Okay, and we can repeat the same process exactly for the different numbers of seconds. 6 seconds, we can come out here and go, okay, what happened now? Looks like 20 feet for Shelley, and it looks like 15 feet for Cluck. And it's not real rocket science at this point, just reading numbers out of the graph. 8 seconds. Okay, come out here to 8 seconds. And I don't have any points, okay, in my graph. So what might we be able to do at this point? Okay, all the points that I had, which I've drawn all over, okay, but all the points that you see there on the green line and the red line, those were all of the points that I had in the charts. Okay, so what can we do to find out what's going on with these values outside of what we've got? Okay, what ideas do you have? How can we figure out some extra numbers of seconds beyond what we've got? I mean, should we just use our chart or our graph here and eyeball it? Maybe not the best answer. I mean, if we had a multiple choice question, we might be able to eyeball it and match it up with a correct answer. Okay, but let's say it's a free response question like we've got here, or maybe a gridded question like we see sometimes on our tests. Okay, what else could we do? I can think of a couple of pretty good strategies. Anybody take a stab at one? Yeah, I realize it's Tuesday, but for you guys, it kind of feels like Monday morning. But that means that we are awake and participating today. Okay, I expect an answer. What can we do? You need to be able to figure these out. What kind of a strategy can you use to figure out what may be going on out here at 8 seconds since we don't have any points marked on the graph yet? Check slope. Yeah, we could do that. Figure out how much it's moving, or each graph is moving, and we have those values right here. Okay, we could continue to slope it up. Actually, that wasn't one of the ones I was thinking about. That's a good strategy as well. Okay, so going along with what Patrick just said about slope, could we use the slope about what's going on with the lines and extend the charts further? Yeah, we could do that, which would be the same thing as what Patrick just said about extending the slopes. Okay, and guys, if you know an equation for your lines, okay, like we do know, we figured out these equations back here, this y equals 4x plus 0 and y equals 5x minus 10. If we know the equations, okay, can you take them and put them in your calculator and then use the chart that's in the calculator to find any points that you could ever need? Like what if they asked what happens after 192 seconds? Well, that might take forever for us to chart it out in a graph, or to draw, or to, I mean, sorry, to graph it in a graph, or to fill out a chart or something like that. But if you knew what equation you were looking at, okay, like this y equals 4x plus 0, you could take your calculator and go, okay, y equals 4x plus 0, which we don't actually have to type the plus 0. Doesn't change the equation. And I believe the other equation was y equals 5x minus 10. Okay. Remember that your calculator comes with a built-in table in it. Anytime you get an equation typed into your calculator, all you have to do is go second graph. That gets you the table, if I can get it. And look what you've got. This looks a little different from some of the tables that you've seen in the past. Okay, what's so different about it? Two different y columns. Okay, why two different y columns going on right now? I take a stab at that one. Why two different y columns? Usually we have an x column and a y column that goes with it. Now we got y1 and y2. Anybody know? Exactly. There's more than one line. When you look into your y equals menu, your equation editor, what have you got? You've got two equations. Okay, and you've actually got room for more. You can type up to 10 different equations into your calculator at exactly the same time to graph them at exactly the same time, which means that in your table, however many y equations you have, how many distinct equations, you're going to have a y column, one for each of them. Okay, well, the first one I typed in, that was Shelley, y equals 4x plus 0. So right there for that y1 column, that's Shelley's column. That's her equation. That's the eggs equation rolling down the hill. So if you wanted to know what Shelley was doing after, what was it, 8 seconds that they said? Okay, well, all you have to do is scroll down to where x equals 8, and it would tell you exactly what Shelley is doing, because that was equation number 1. So we see 32 seconds right there, or 32 feet traveled after 8 seconds. And y2 was Cluck's equation. Okay, y equals, okay, 5x minus 10. In that case, it gives us 30 feet. Okay, so there are actually your answers. Okay, Shelley has traveled 32 feet and Cluck has traveled 30 feet. So Cluck's about to catch up, but hadn't quite yet. Okay, and guys, you got to realize these charts, these are infinite. You can, like I said, if you wanted to know what's going on after 192 seconds or whatever, if the hill was that long and this chase could continue that long, you can find that in your table if you can simply put the equations into the calculator. Okay, but anyway, there it was, and I believe the answer was, if I remember correctly, 32 feet and 30 feet. Okay, so a bunch of different ways of doing that. Okay. All right, so there's a couple of real good strategies there. We can extend our chart further. We can observe our slope, as Patrick suggested a minute ago, in order to plot more and more points. We can use our calculator. Okay. There's actually one more if you're a little bit more advanced of a mathematician. Okay. There's a little bit better way of going about this. Okay, and actually a little bit less work to do it this way. How far will Shelley and Cluck be after 4 seconds and 6 seconds and 8 seconds and 92 seconds and 100 million seconds and all that kind of stuff? There's another way to do this, folks. Your equations have variables in them. Y. What does y represent? Well, the y-axis is representing distance. Okay. Your equation also has x's in it. What does the x represent? Time. So if you ever wanted to know anything about either one of these equations, all you would need to know is one piece of information. If they wanted to say, hey, how far has Shelley traveled after 52 seconds? Well, there's Shelley's time. If you wanted to know how far Shelley had traveled after 52 seconds, then you would simply plug in a 52 for time, and that would tell you how far Shelley has traveled. If they said, if Cluck has traveled 122 feet, then how many seconds has she been running? Well, there is the distance that Cluck has traveled. So if you wanted to know after 122 feet, how many seconds has she traveled? Well, you just plug in the piece of information that you do know where it goes, and that will tell you the other piece of information. So if you are comfortable with recognizing a number that they give you, like 4 seconds or 6 seconds or 8 seconds, you can simply plug it in for time, and that will tell you what distance is going to do. Okay? So that's another way to go about it. Okay, let's move on to question number 12. 12 asks, if Shelley is 20 feet down the hill, how long has she been rolling? Well, there's a pretty good opportunity for us to use what we're just talking about there. If Shelley, which is this equation, is 22 feet down the hill, which variable is that? Is that y or x or what? That's y, okay, right? Because distance is on our y-axis. So right now, they are establishing that Shelley is 20 feet down the hill, and they want to know how long has she been rolling. Well, that is 20 equals 4 times x, and then plus 0 is plus 0, and all we have to do is solve for x. Well, how would you solve for x right here? There's only one thing you got to do. What would you do? Divide by 4. You've got 4 x's right now. You don't want 4 of them, you just want 1. So if we divide both sides by 4, then Shelley has been traveling for 5 seconds. And there you go. It's really that simple. Okay, but it's also as simple as any other thing. You can use the chart, you can use the graph, you can use slope, you can program your calculator, you can look in the table in the calculator. You've got a lot of options. I don't care which one you use. I just care that you get the right answer. So pick one you like and do it. Okay, let's finish off the rest of these. Number 13, if Cluck is 35 feet down the hill, how long has Shelley been rolling, and how long has Cluck been chasing Shelley? Well, that's kind of an interesting question. They've got several things for us to look at. Okay, so Cluck. All right, well, here's Cluck. And they say she is 35 feet down the hill. How long has Shelley been rolling? Okay, well, I don't know. They give us information about Cluck, and then they ask us about Shelley. So we probably better figure out whatever we can about Cluck and then see how that applies to Shelley, the egg. Okay, so let's see what we've got there. That says 35 equals 5x minus 10. Okay, well, we need to solve that thing. Okay, what would be the first thing you would do to solve this equation? What would you want to do first? Yeah, follow your 5 steps. Okay, eliminate any parentheses or restrictive items that you have. Combine like terms if you can. Get all your variables that you're looking at together, and get all the way to step 4 before we find anything to do, and that's isolate your variable. Well, you got 5x's over here on the right, but they've got minus 10 attached to them. We don't want minus 10 attached to them, so we're going to move the minus 10. Okay. And as Clarissa said, we're going to add 10 to both sides in order to get that done. Minus 10 plus 10. That cancels right there, and that leaves us with 45 equals 5x. The final step is to get just one x. We don't want 5 of them, we just want one. So we're going to move the 5 by dividing by 5. Divide both sides by 5. And that's going to tell us that in order to be 35 feet down the hill, Cluck has been running for 9 seconds. Okay. Now, the question is, how long has Shelley been rolling? Okay. Now, 9 seconds have gone by, is what we just discovered. Okay. And we could track that all the way up the graph to find out what's going on up there, and that's kind of fine too. Okay. How long has Shelley been rolling? Okay. Well, that may be so easy it almost sounds like a trick question. Okay. Well, how many seconds have gone by? 9 seconds have gone by. Okay. So how long has Shelley been rolling? Shelley's been rolling for 9 seconds. Now, a different interesting question would have been, how long has Cluck been running? What would you say if they asked, how long has Cluck been running? Has Cluck been running for 9 seconds? I mean, Shelley's been rolling for 9 seconds. Did Cluck run for 9 seconds? Have a look at the graph. What do you think? It's not a trick. Just read the graph. How long has Cluck been running? Does Cluck start back here running? No, Cluck starts here running, right? Well, so that's from 2 seconds to 9 seconds. Cluck has been running for 7. Shelley's been rolling for 9. So they could have easily turned that around a different direction. See if we're paying attention. Okay. Now, how long has Cluck been chasing Shelley? I got ahead of myself. The next question kind of asked that, didn't it? How long has Cluck been chasing Shelley? Well, because of that 2-second head start, Cluck's only been chasing for 7 seconds. Okay. When and where will Cluck catch Shelley? Okay. What can we do? What can we do to figure out what will happen to these two lines? They're continuing to go up. Where would we find that they're going to catch each other? What would we see in a graph when one catches the other? They're going to be two separate lines at that point? That's going to be the place where they cross over each other, right? That's going to be the intersection. Okay. So at that point in time, we kind of want to know where they cross. Where is that point where they cross? And this is what the entire previous unit, this is what all of Unit 6 was all about, figuring out where two lines cross each other. Okay. So to do that, we go into the Calculate menu. Okay. Option number 5 for intersect. Okay, I'm not entirely sure that we have the intersection in the screen there, so I'm actually going to zoom out a little bit. Okay, now the intersection's in the screen, but I really having kind of some trouble figuring out where it is. So actually, I'm going to zoom back in. If I can get my calculator to cooperate. Come on. So I'm going to kind of focus on where I think the intersection is at and maybe get a little bit closer look at it. I think pretty clear that we've got it right in this area. So go second calculate, option number 5 is intersect. And remember, just scroll yourself kind of near the intersection. Doesn't have to be perfect. And you just go enter, enter, enter. And there we go. We have a value of x equals 10 and y equals 40. Okay, so again, x equals 10, y equals 40. Let's see if we can figure this out. When and where will Cluck catch Shelley? Well, which one of these two values is the when? That's when and where. Which one is when? You got 10 and you've got 40. Which one's when? Here's your when is time. That's your x value. And your where is distance. That's your y value. So if we had x equals 10 and y equals 40, then when is 10 seconds and where is 40 feet. Okay. And lastly, number 15 asks, will Cluck be in time to save Shelley from cracking her noggin at the bottom of the hill? Explain your conclusion. Well, it's been a while since we read this thing. Back in the beginning, we had a scenario. Okay, it said Cluck the chicken was at the top of Poultry Promontory nesting Shelley her egg. Shelley decided to take off on an adventure, began to roll down the 45-foot slope of the hill at a rate of 4 feet per second. Okay, well, 45 feet. Well, let's see. Did you make it in time? No, only 40 feet had gone by. Okay, and it said that the hill was 45 feet. So will Cluck be in time to save Shelley? The answer is yes. Okay, and on an explanation, there's a lot of different ways you could do it or word it or whatever. Okay, it'd be probably just the easiest thing to say is that there were 5 more feet to the hill. So another 5 feet, and she wouldn't have made it. Okay. So since Cluck was moving at 5 feet per second, I guess if Cluck had just let 1 more second go by before she realized, then the egg is probably broken at the bottom of the hill. Okay. So that concludes the activity that we were doing on Friday in groups. Okay. And now what we're going to do is we're going to move forward and we're going to take a look at the next lesson. Okay, now I'm going to go over some examples with you, kind of as many as I can here. The big challenge of this unit is going to be you're still working in systems like you were last unit. Okay, so you're going to be answering questions just like we were answering there about Cluck and Shelley. Now, those questions are not all that difficult. As we've seen, there's a lot of different ways to do them, a lot of different strategies we can work. Okay, so if you kind of know any strategy of working those problems, whether it be a chart or understanding slope or drawing a graph or using your calculator or writing an equation, there's a lot of different ways to work it. And as long as you can find any way that works it, then you're probably in pretty good shape. The problem is going to be that they may not hand us as much information as we just saw with Cluck and Shelley. With Cluck and Shelley, they started it off a graph. They kind of had it working for us, and then we had to kind of figure out how everything would work from there. Well, it's entirely possible that they may not start us off with that much information. Okay, so this is kind of like what happened in Unit 6, where we started off, where we kind of got led down the road, and then we had to figure it out. Okay, so the challenge is going to be getting the information out of the problem and at least getting it started for ourselves so we can figure out what's going on. So let's take a look at these. You're going to see that there's a lot of different types of problems. We could probably work these problems from now until the end of the year and never really cover everything that could be done. Okay, so let's see if we can figure that out. Okay. Question number 1. Teresa has a total of 40 DVDs in 2 categories. The number of her action DVDs is 10 more than twice the number of her documentary DVDs. Determine a system of equations that can be used to find how many action DVDs, A, and documentary DVDs, D, Teresa has. Okay. Well, this is, I mean, it sounds bad. Okay, it sounds bad. It's got a lot of words to it and all that kind of stuff. So let's see if we can't decode what it actually. Okay. All right, now it asks first off, what are the 2 variables and what does each represent? Okay, well, this is pretty obvious. Okay, they identify this for us in the problem. Okay, so we can probably assume at some point in time they're not going to identify it for us. They're going to just kind of throw a problem at us. It'll be up to us to figure it out. But in this case, okay, we've got 2 variables. We've got an A and we've got a D, and they ask us to identify them. Well, it's already identified. Okay, how many action DVDs, A? Okay, and how many documentary DVDs? d that are in the problem. Okay. Now, what two equations can be formulated for the information in the problem using the variables? Well, I don't know. Let's read back over it again, see if we can figure it out. Okay. Teresa has a total of 40 DVDs in 2 categories. Can anybody figure out a way to use these 2 variables that we already have that would tell us, okay, some type of an equation that would tell us that she has 40 of them? What could you say? Something is going to have to equal 40 because 40 is a total. Okay. What equals 40? Okay. Well, since nobody has any thoughts on it, how about just simply the amount of action DVDs that she has added to the number of documentary DVDs that she has needs to equal 40. That makes sense? That's pretty obvious. That's something we need to be able to come to. Action plus documentary is going to equal 40. They still told us she had 40. Let's see what else we can figure out. The number of her action DVDs is 10 more than twice the number of her documentary DVDs. Okay. Well, all in one sentence, that's pretty ominous. Okay. That's difficult to understand what that says. Let's just take it a couple words at a time here. The number of her action DVDs. What do you know about that? Action DVDs. Okay, well, let's see. Let's just start off with this. Action DVDs, A. That's the variable A, right? Okay, so if you wanted to, you could actually just say, all right, I've taken that whole thing out. I've taken care of all of that. That is A. Okay, and it says is. What's is in a math problem? Equals. The word is typically means equals. Okay, and then it says 10 more than. What's 10 more than? What's another way to put 10 more than? 10 plus something, right? Something's going to get 10 added to it. And then it says twice the number. Twice the number. What happens there? Yeah, something's doubling, right? Something's getting twice as big as it was. So we're going to get 2 times something. 2 times what? Her documentary DVDs. What do you know about those? D. And you can even read this thing back to see if it sounds like what you just said. Her number of action DVDs is going to be equal to 10 more than, or 10 plus, double her number of documentary DVDs. Sound like it says the same thing from the word problem? Sounds pretty reasonable. Okay, well, there you go. You have 2 equations that are written in terms of the variables that are in the problems. You just wrote a system of equations. C, solve the system of equations to find the number of action and documentary DVDs Teresa has. Okay, well, we've been talking about a lot of different strategies. Charts, graphs, calculator, okay, figuring out slope, a lot of different things we can do. Okay, can anybody think of a problem we're going to face right now? What's so different about this system of equations than the system of equations we are used to seeing? Anybody sum it up? What's so different? There's a couple of things that are different. Okay. Anybody spot one thing? Okay. All right. Now there's a couple different ways. The point that was made was that we might be used to seeing things in slope-intercept form. Okay. How about this first equation? Is this first equation in slope-intercept form? No, it's not. And first off, and you come back to it and you can say, hey, what about the idea of slope-intercept form? Y equals mx plus b. Do we have y's and x's in this system? We sure don't. Okay, we sure don't. So that's a couple of things. Is this first equation is not in slope-intercept form, and even if it was, the variables wouldn't be the same. Okay, and on the topic of the variables, is your calculator going to understand what you're talking about with a's and d's rather than x's and y's? The calculator is all about the y's and the x's that go with them. Okay, so what we might want to do is we might want to figure out if it was going to be in slope-intercept form, what would it look like? And if we wanted to talk to our calculator about the system, okay, what might the system say? Instead of A's and D's, could we convert it over to X's and Y's so the calculator could understand it? And the answer is yes, you can convert to X's and Y's as long as you remember how you converted it. Okay, so let's start with the obvious. Okay, I'm going to take that top equation right there, and I'm going to convert it to, as Clarissa said, slope-intercept form. Okay, well, this bottom one, is it kind of slope-intercept form? You got a variable equals everything else. That's kind of what slope-intercept form does, right? Y equals everything else. This bottom equation is pretty good. Okay, bottom equation is pretty good. Now, if we could get the top equation to do basically the same thing, well, on this bottom one, A is already isolated. So how about let's get A isolated right there. Okay, if I wanted A to be by itself in this top equation, what would I have to do? Subtract D to the other side, right? So if I subtracted D from both sides, I would end up with A equals 40 minus D. Well, at that point, at least you've got the same variable isolated in both cases. Okay, now, if we wanted to use our calculator to help us out, well, let's think about it for a second. What variable does our calculator like to have isolated? It likes to have y isolated, right? So could I just make myself a little note and say, hey, I'm going to take all the a's out of this problem, and I'm going to turn them into y's. So instead of my equation saying a equals, they're both going to say y equals. And so, you know what, I'm also going to take the d's out of this equation, and I'm going to turn them into x's. In which case, your top equation would say y equals 40 minus x, and your bottom equation would say 10 plus 2x. All we've done is just kind of change the variables out for each other so that the calculator can understand our problem. Using a system that's got x's and y's in it, we can do anything we want. We can chart, we can graph, we can slope, we can use our calculator, we can do all that stuff. And then in the end, whatever answers we get out of our calculator, x equals some number, y equals some number, then we can come back to our little legend, our little key that we made over here, and change them back into A's and D's instead of X's and Y's. Then we should be able to answer any question that they want to ask about it. Okay, so let's do that. Okay. All right, so let's see if we can't program these two equations here. So I'm going to bring my calculator back up. First thing I'm going to do is fix my window going back to Zoom Standard. And then I'm going to go back into my equation editor, y equals. Clear those equations out, and let's enter our new ones here. 40 minus x, I'm just typing them up. 40 minus x and 10 plus 2x. Okay, so there they are. We can graph them, see what they're doing. Wonder if my intersection is going to be in the screen or not. Nope, calculator's finished thinking, and the other line is not even in the screen. Okay, so we're going to zoom out. Let's get a bigger picture. Zoom out, option 3, enter. There's the other line. Good, we got a nice clean intersection right there in the screen. We can see it. Calculate, option 5 for intersect. Bring our cursor down. Just get it close. Pretty good. Enter, enter, enter. All right, x is 10, y is 30. X is 10, y is 30. Okay. Find the number of action documentary DVDs, or action and documentary DVDs that Teresa has. Well, let's see what we have here. Action. Okay. How many action DVDs does she have? Action was the variable that got changed off with y. Okay, so how many action DVDs does she have? She's got 30 of them. How many documentary DVDs does she have? Okay, yeah. D is the variable that got changed out for the x, and we just figured out that our x was going to be 10. That is the answer to those two questions. Took us a little longer to get to it, but once you get in the habit of it, it won't take that long. Question D here, is the solution reasonable to the problem situation? Okay, I guess what they're asking us to do here is to see if the original problem matches up with the answers we just came up with. Teresa has a total of 40 DVDs. Does she, according to our answer? We got 30, we got 10, is that 40? Yeah, so that part of our answer makes some sense. Okay. What else do we have? The number of action DVDs is 10 more than twice the number of her documentaries. Well, we said she's got 10 documentaries, and it said that she's got 10 more than twice that. Well, what would be twice? Be 20, right? 10 more than that would be 30. Is that what we came up with for the action DVDs? You bet. Okay. This is what we call checking our answer for reasonableness. Okay. Do the numbers that we came up with make sense to the problem that they asked? Okay. And the answer would be yes. Okay. And explanation would be something along the lines of fits the problem. Okay. You don't have to get real creative with your explanations. It just needs to explain something, okay, that goes along with what you're thinking. Okay, we'll pick it up there. We have some more problems to look at, some more examples I want to go over with you before I turn you loose on these on your own, and also some different types of word problems that operate a little bit differently than these. So again, we'll pick it up tomorrow, and then we'll finally get to an assignment tomorrow at the end of class.